Okay, let's start by setting up our environment. Then we'll use the most basic command, which is do TTS. It takes two arguments that are required. One is the text that you want to say, and the other is the name of the voice that you want to render. It takes a few seconds to render. In fact, it takes quite a long time, and that's why it's called tortoise. Once it's rendered, you'll have 3 candidate renders that are saved to the default results folder. I've made some modifications along the way to expose some other parameters. I tend to render things with the same seed of 1000, in case I want to come back and re-render it again if there's a text change. The CVVP amount is a value between 0 and 1, where 1 will pay the most attention to the inference voice, and 0 will pay the most attention to the text. I expose the temperature value, which normally defaults to 0.8, but by exposing that, I can either shut it down towards 0, where it will have much less variation among the candidates, or crank it all the way up to 2, where it will take some wild chances. I've also set up a settings file that has parameters for each of the character voices, so I'm able to specify the recipe and the parameters that go with that voice. In that way, I can do bulk script rendering. Now, scripts fall into a couple of different formats. The simplest and quickest one is just the file name, without the extension, a tab character, and then the text string that you want to render. Now, quite often, the dialogue lines that you get from the game are way too long and need to be cut up into shorter phrases. I find that Tortoise can only handle lines of about 250 to 300 characters long before it kind of tops out on memory. It makes them go kinda crazier. So I'll break the line up into individual phrases which I can concatenate back together later. Once the script is prepared, I run another Python script that I wrote for bulk generation. When you run that, then it's time to go out for lunch or something while it takes a long time to render.
5 hours later.
When you come back, you've got a folder full of takes. You could really specify any number of takes per line, but I find 5 is a pretty good number. And then I can open up the script in another tool I've written for choosing takes. You can audition each of the takes and choose your favorite, line by line. When you do that, you can open them up in another editor if you need to make any manual edits. In any case, once I've chosen all my takes, I can then concatenate them back together. Now, what's really happening behind the scenes is, as I choose takes, each one that I favorite gets copied from the takes folder into the foreground folder. Let's say, for example, I favorited take number 3. It will make a copy of the take and bring that out into the foreground folder and rename it without the take extension. Once I have a folder of master choices, I can select concatenate, and it will put each of the series back together, concatenated into masters in a concatenated folder. At the same time, it's doing some SOX processing to do level matching and a little bit of equalization, where it will roll off some subsonic rumble and things like that. You know, just as detailed and fucking fantastic. The second, more complex kind of script is a CSV file in Excel. The first column is the node ID. Typically in games, most conversational systems are turn-based state machines that manage the conversation between an NPC and a user. So a line of dialogue usually corresponds to one of the nodes in a dialogue tree. The second column is the character name. This will be used to look up in the character settings file to pull the right voice recipe for that particular character. The dialogue package name is usually the asset name of the specific dialogue tree within the build. The column labeled expected sound wave name should conform to a naming convention that contains information about the quest, character, and game state. A well-organized naming convention is a beautiful thing. Ideally, every game has a human interpretable naming convention for keeping track of assets. Then there's the text field, which contains the dialogue that appears on screen. This may have some pesky markup we don't want spoken in the rendering, like italics, bolding, or links. So that's why we keep it separate from the TTS text column. At first, the text is just a raw copy of the text from the text field. But this allows me to cheat it with punctuation or phonetic spellings if I need to make the TTS behave in a certain way. Ideally, when I check this file and the audio back into the build, the TTS field also gets ingested and updated. That way, if ever there are dialogue changes down the road, we can pick up where we left off. We're always fine-tuning the text strings, building up the assets, and getting closer to a final performance for the character. I also recommend the last column called redo. Initially, this defaults to 1, meaning that line gets rendered, and once it's rendered, it's set to 0. Now, if it turns out that rewrites or pickups are needed for 1 or 2 lines, I check out the script from the build. The keepers are set to 0, and the system will only rework the lines I want to re-render. So that's very helpful. I have a separate piece of Python code for scripts of this format that'll step through the script. Look up the right voice recipe, send the parameterized performance data to the renderer. And again, we're generating the 5 candidate takes. Then, just as before, you can go through and choose your favorite takes and check your updates back into the build. And that's basically it. Any questions?